let's go ahead and jump into chapter 2, exercise 10. And this is probably the first exercise, I would say, that we're doing something interesting. And that is we're implementing what's known as basic calculation, basic calculator, using what is known as using as prefix notation. And prefix notation just means that the operand becomes at the beginning of the line. Most of the time what we're used to is to have infix notation, so something like 3 plus 5. In prefix, though, we would write plus 3, 5. This is somewhat of an older way of doing things. This is how really old school calculators used to work, and we can talk a little bit more as to why that's the case. But suffice it to say that when you're dealing with very little memory and with very little compute power, it is actually easier to parse a prefix notation than it is to do in infix. So let's go ahead and implement this. And I'll walk you through the thinking here a little bit, but right now there actually isn't very much. Eventually, I suspect in the course of the book, we are going to get to a place where we're going to do slightly more sophisticated things with the prefix notation and really be able to build out a fully functioning calculator. But let's start out with this. Okay, so what we need right now is int operand, and we need, sorry, not int, this would be a string operand. And what we're going to do is we're going to have op1, we'll really say val1 and val2, and I'm also going to do a separate one for results, so we keep things a little bit cleaner in terms of how we're presenting things. Also, let's go ahead and ask the user for input. Please enter calculation input, and then we're going to go ahead and parse things in. And so first we're going to grab the operand, then we're going to get value 1, and then we're going to get value 2. This is an important idea in terms of what's going on here, because especially for something like division or subtraction, order of operations matter, unlike for addition or multiplication. So we want to just keep this in mind. Won't really be necessary quite a bit for this assignment, but for future cases when we're dealing with this, it will likely be something that is much more relevant. So let's go ahead and figure out what we're going to do. So if operand is equal to plus, we have to do string plus, not character plus. So what we know is that result is going to equal to value 1 plus value 2. And then if operand is equal to minus, then we're going to say result is going to equal to value 1 minus value 2. This is the important part, because if you mess this up, the order of operations for subtraction matters. If operand is equal to times, then result is equal to value 1 times value 2. And finally, if operand is equal to divide, then result is equal to value 1 divided by value 2. And let's go ahead and print this out, and we will say, let's be a little bit fancy here, and we'll write it like this. Val1 space operand space val2 space is equal to result. And that should be it. Okay, and let's go ahead and run this example and see what we get. Make sure that it all works. It's going to compile. And let's see, let's go ahead and do plus space 100, 3.14, and we expect it to be 100 and 3.4. Let's do it one more time. Run code, and we'll do times 4, 5. We should get 20. There it is, beautiful. And let's do division. Actually, let's do all of them. So let's do minus 34.55. And then let's do a negative number, minus 123.45. we expect this to actually be a positive value, right? 158, because minus times a positive is going to be a positive value. And then let's do one more to make sure that we get the division right. So let's divide 32.44, and let's pick some other number, 55.78. No real meaning, and there it is, and we got it. So it looks like everything's working correctly. So the program is doing the right thing. Let's go ahead and ship it. All good.